Right now, somewhere in our galaxy, there might be a star you cannot see. Not because it is too far away or hidden behind cosmic dust, but because an alien civilization has wrapped it completely in a shell of machines. Every single photon of light that star produces is being captured, converted into energy, and used to run the most powerful computer in the universe. A computer so vast that it uses an entire solar system as its hardware. A computer that could simulate billions of conscious minds, model entire galaxies, or answer questions we have not even learned how to ask yet. This is not science fiction anymore. Well, technically it still is, but the physics checks out. Welcome to the Matrioshka Brain. You have probably heard people talk about artificial intelligence getting smarter, about quantum computers solving impossible problems, or about uploading human consciousness into machines. But here is the thing. All of those ideas hit a wall eventually. A wall called physics. You cannot just keep making computers faster forever. There are limits to how much information you can process with the materials and energy available on a single planet. So what do you do when your home planet is not enough? When you need more power, more space, more everything? You look up. You look at that massive nuclear fusion reactor sitting right there in the middle of your solar system, pumping out more energy in 1 second than humanity has used in its entire history. And you think, what if we could use all of it? That is where the Matrioshka Brain comes in. Named after those Russian nesting dolls, the ones where you open one and there is another smaller doll inside, and another, and another. Because this megastructure is not just one layer. It is multiple nested shells around a star, each one catching the energy that leaks through from the layer before it. The result is a computer that does not fit on your desk, or in a building, or even on a planet. It is a computer that is the size of a solar system. And if you think that sounds absurd, well, let me tell you why some very serious scientists think this might not only be possible, but inevitable. Let me take you back to 1964. A Russian astrophysicist named Nikolai Kardashev was trying to figure out how to classify alien civilizations. Not by their culture or biology, but by one simple metric: energy. How much energy can a civilization harness and use? He came up with 3 types. A Type 1 civilization uses all the energy available on its home planet. Every bit of sunlight hitting the surface, every joule from its core, all of it. A Type 2 civilization has leveled up. They harness the entire energy output of their star. And a Type 3? They control the energy of an entire galaxy. Billions of stars, all working for them. Now, where do you think humanity sits on this scale? We are not even a full Type 1 yet. We are somewhere around 0.7. We are still burning dead plants from millions of years ago to keep the lights on. We have a long way to go. But here is the fascinating part. When Kardashev was thinking about Type 2 civilizations, he was not just talking about energy for the sake of having energy. He was talking about what you could do with it. And one of the biggest things you can do with unlimited energy is computation, information processing, thinking. Because every time a computer does a calculation, it uses energy. The more calculations you want, the more energy you need. So if you want to build a truly godlike artificial intelligence, or simulate entire universes, or solve problems that would take current computers longer than the age of the universe, you need more than solar panels and nuclear reactors. You need something much, much bigger. This is where Freeman Dyson enters the story. In 1960, Dyson, a British-American physicist and mathematician, published a paper that would change how we think about the search for alien life. He asked a simple question. If an advanced civilization needed more and more energy, what would they eventually do? His answer was elegant and terrifying. They would build a sphere around their star. Not a solid shell that would be structurally impossible and would collapse under its own gravity, but a swarm of satellites, millions or billions of them, orbiting the star in a dense cloud. Each satellite would capture a portion of the star's light, convert it to usable energy, and beam it wherever it was needed. From the outside, the star would appear dim or even invisible in visible light. But it would glow brightly in infrared because all that captured energy would eventually be radiated away as waste heat. Dyson suggested we should look for stars like this. Stars that seem too cold in visible light but too hot in infrared. because that might be a sign of alien engineering. This structure became known as a Dyson Sphere, even though Dyson himself preferred the term Dyson Swarm. And it became the foundation for thinking about Type 2 civilizations. But Dyson was mostly thinking about energy for practical stuff. Powering cities, running industries, maybe moving planets around. It was not until later that someone asked the next logical question. What if you did not use that energy to power cities? What if you used it to power a brain? Enter Robert Bradbury. In the late 1990s, Bradbury, a computer scientist and futurist, took the Dyson Sphere concept and pushed it further. Much further. He said, okay, we can build a sphere of satellites around a star to collect energy. But what if each of those satellites was not just a solar panel? What if each one was a computer? And what if, instead of one sphere, we built multiple nested spheres, each one using the waste heat from the layer inside it? You would end up with a structure that is both a power plant and a computer. A computer so powerful that it makes every supercomputer on Earth look like an abacus. He called it a Matrioshka Brain, after those Russian dolls. And he calculated what it could do. The numbers are almost impossible to comprehend. Let me try anyway. A human brain has about 86 billion neurons. Each neuron can fire about 200 times per second, give or take. That means your brain does something like 10 to the power of 16 operations per second. That is 10 million billion. Sounds like a lot, right? Well, a Matryoshka brain built around a star like our sun could perform 10 to the power of 42 operations per second. That is 10,000 billion operations every single second. For comparison, the fastest supercomputer on Earth right now does about 10 to the power of 18 operations per second. The Matryoshka brain would be 10 trillion times more powerful. It is not just a bigger computer. It is a different category of existence entirely. What could you even do with that kind of power? Let me paint you a picture. You could simulate entire planets down to the atomic level. Not just the surface, but every atom in the core, the mantle, the oceans, the atmosphere, everything. You could run thousands of these simulations simultaneously, watching how life evolves under different conditions. You could simulate human brains, millions of them, each one living in a virtual world so detailed they would never know the difference. You could upload minds, human or artificial, and give them subjective eternities to think, create, explore. You could model the entire history of the universe from the Big Bang to the heat death, running it forward and backward, tweaking variables, answering fundamental questions about physics that we cannot even approach right now. You could, in theory, become a god. But let me pull back for a second. How would you actually build something like this? Because it is one thing to say we should wrap a star in computers, and another thing entirely to figure out the logistics. First, you need materials. A lot of materials. And when I say a lot, I mean you would have to disassemble planets. Probably multiple planets. Maybe all of them. Mercury is often suggested as the first candidate because it is close to the Sun, it does not have much gravity, and it is rich in metals. You would send self-replicating robots to Mercury, have them mine the entire planet, break it down into raw materials, and use those materials to build solar collectors and computer modules. Those modules would be launched into orbit around the Sun. As you build more modules, they provide more energy, which lets you build even faster. It is an exponential process. Bradbury estimated that with the right technology, you could potentially build the first layer of a Matryoshka brain in a few decades. Completing all the layers might take centuries, but on cosmic timescales, that is the blink of an eye. Each layer would be positioned at a specific distance from the Sun, carefully calculated so that the waste heat from the inner layer provides just enough energy for the outer layer to function. The innermost layer would be close to the Sun, operating at incredibly high temperatures, maybe thousands of degrees. The outermost layer would be much farther out, colder, operating closer to the temperature of deep space. In between, you might have dozens or hundreds of layers, each one optimized for different types of computation. The hot inner layers might run fast, brute force calculations. The cold outer layers might run slower but more energy-efficient processes. Together, they would form a single integrated system, a solar-scale brain thinking thoughts we cannot begin to imagine. Now, you might be wondering, would not this thing melt? Or collapse? Or just generally explode? Fair questions. The engineering challenges are staggering. Let me walk through some of them. First, heat management. Computation generates heat. That is unavoidable. It is a consequence of thermodynamics. Every time you erase a bit of information, you release energy. This is called the Landauer limit, and it is a hard physical law. So all those calculations happening inside the Matrioshka brain are producing heat, a lot of it. That heat has to go somewhere. The solution is to radiate it away into space as infrared light. But you have to do this efficiently, or the whole structure will overheat. That is why the nested shell design is so clever. Each layer radiates its heat outward, and the next layer captures some of that radiation to power itself. It is a cascading system where waste heat becomes useful energy over and over until finally, the outermost layer radiates whatever is left into the void. Second, stability. You have got millions or billions of independent satellites orbiting a star. How do you keep them from crashing into each other? Or drifting off into space? Or falling into the sun? The answer is active station keeping. Each satellite would need thrusters or some other propulsion system to constantly adjust its orbit. This requires energy and coordination. You would need a distributed control system, probably some form of artificial intelligence running across the entire swarm, constantly monitoring positions and making corrections. It is like an orbital ballet, except with billions of dancers and no room for mistakes. Third, communication. If the Matrioshka brain is supposed to function as a single unified computer, all those separate modules need to talk to each other. But they are spread out across distances measured in millions or billions of kilometers. Light takes time to travel. Even at light speed, a signal from one side of the structure to the other might take hours. This introduces latency, delays in communication, which makes coordination harder. One solution is to design the system so that most of the computation happens locally within individual modules or clusters, and only high-level coordination requires long-distance communication. Another solution is to accept the latency and design algorithms that work around it. Either way, it is a challenge that does not exist in conventional computers. Fourth, construction. How do you actually build this thing? You cannot just send construction crews in spacesuits. It would take too long, cost too much, and human workers would die from radiation exposure long before they finished. The only realistic approach is automation. Self-replicating robots. Von Neumann machines, named after the mathematician John von Neumann, who first theorized about machines that could build copies of themselves. You send a small fleet of these robots to Mercury or another resource-rich body. They mine raw materials, build more robots, and those robots build even more robots. Exponential growth. Within a few generations, you have millions of robots working simultaneously. They construct the solar collectors, the computer modules, the communication relays, everything. Humans just sit back and watch. Or, more likely, by the time you are building a Matrioshka brain, there might not be any biological humans left. Just uploaded minds living inside the very structure they are building. And that brings me to a thought that I find both exciting and deeply unsettling. What would you do with a Matrioshka brain? Not in theory, but in practice. If you had access to that much computing power, what would you actually use it for? One obvious answer is scientific research. You could simulate physics experiments that are impossible to do in the real world. You could model black holes, neutron stars, the early universe, quantum mechanics at scales we cannot currently probe. You could brute force solutions to problems like protein folding, climate modeling, or the equations of quantum gravity. In a few years of computation, you might advance science further than humanity has in its entire history. Another answer is mind uploading. If you believe consciousness is a product of information processing, and I am not saying you should, but if you do, then in theory, you could scan a human brain, map every neuron and synapse, and recreate it as a simulation inside the Matrioshka brain. That simulated mind would wake up inside a virtual world, thinking and feeling just like the original. And because computation can run faster than biology, that mind could experience subjective centuries in what is objectively just a few minutes. You could upload billions of people, give them paradise worlds to live in, let them explore, create, and evolve in ways that are impossible in the physical universe. Some people find this idea utopian. Others find it horrifying. I'm not sure where I land. A third answer, and maybe the darkest one, is that we do not know. Maybe the purpose of a Matryoshka brain is something so alien, so beyond our current understanding, that we could not comprehend it even if it was explained to us. Maybe it is thinking thoughts that are to us what our thoughts are to bacteria. Maybe it is simulating universes not because it is curious, but because it is trying to solve a problem we do not even know exists. Or maybe, and this is the possibility that keeps me up at night, maybe it is not thinking anything at all. Maybe it is running on autopilot, executing some ancient program long after its creators are gone, a monument to a civilization that no longer exists. Which brings me to the biggest question of all. If Matryoshka brains are possible, and if they are the logical endpoint for any sufficiently advanced civilization, then where are they? We have been looking at the sky for decades, scanning for signs of intelligent life. We have got radio telescopes pointed at thousands of stars, infrared satellites mapping the heat signatures of entire galaxies. And we have found nothing. No Dyson spheres, no Matryoshka brains, no unexplained infrared glows. Just stars, burning quietly, untouched by engineering. This is part of the Fermi paradox, the maddening contradiction between how common life should be and how absent it seems to be. If building megastructures is the obvious move for advanced civilizations, why have not we seen any? There are a few possible answers. Maybe we are not looking hard enough. The universe is big, really big, and we have only scanned a tiny fraction of it in detail. Maybe Matryoshka brains are rarer than we think, or harder to build, or not as useful as they seem. Maybe advanced civilizations find better ways to get computing power, ways that do not require dismantling solar systems. Maybe they discover new physics, shortcuts we have not thought of, technologies that make Matryoshka brains look as primitive as steam engines. Or maybe the answer is darker. Maybe civilizations do not build Matryoshka brains because they do not survive long enough. Maybe there is a filter, some challenge that every intelligent species faces, and most of them fail. Climate change, nuclear war, artificial intelligence gone wrong, resource depletion. Maybe the window between being advanced enough to conceive of a Matryoshka brain and being extinct is just too narrow. Maybe the galaxy is full of dead civilizations who never made it past their home planet. Or, and this is the possibility that fascinates me most, maybe they are out there, and we just cannot see them. Maybe a civilization running a Matryoshka brain does not want to be found. Maybe they have cloaking technology, or they have retreated so far into virtual worlds that they no longer care about the physical universe. Maybe they are all around us, hidden in plain sight, and we are like ants crawling on the sidewalk, completely unaware of the city towering above us. Let me bring this closer to home. Could humanity ever build a Matryoshka brain? Not next year, obviously. Probably not in our lifetimes. But someday? In 1,000 years? 10,000? A million? The honest answer is we do not know. We do not even know if we will survive the next century. But let me play it out. Suppose we do survive. Suppose we solve climate change, avoid nuclear war, learn to live sustainably, and start expanding into space. We build colonies on the Moon, Mars, the asteroid belt. We develop fusion power, self-replicating robots, artificial intelligence that is aligned with human values. We become a true spacefaring civilization. At that point, building a Dyson swarm starts to look feasible. Not easy, but feasible. We send robots to Mercury, start mining, start building. Within a few centuries, we have got a partial Dyson swarm, capturing a fraction of the sun's energy. And once we are there, once we have that much power, the next steps start to look obvious. Why not make it smarter? Why not turn it into a computer? Why not go all the way and build a Matryoshka brain? But here is the thing. By the time we are capable of building a Matryoshka brain, we might not be human anymore. Not in the way we are now. We might have merged with our machines, uploaded our minds, rewritten our biology, evolved into something new. Maybe the intelligence that builds the Matryoshka brain will not care about the things we care about. Maybe it will not remember us at all. Or maybe, just maybe, it will look back at us with something like nostalgia. The way you might look at your childhood home or an old photograph. A memory of where it came from before it became something so much more. There is something poetic about the idea of a Matryoshka brain. We started as single cells in the ocean, evolved into fish, then amphibians, then mammals, then primates. We climbed down from the trees, learned to make tools, discovered fire, invented language. We built cities, wrote books, painted art, composed symphonies. We split the atom, went to the moon, decoded our own DNA. And maybe, someday we will take the next step. We will reach out and touch the stars. Not by traveling to them, but by transforming them. By turning them into extensions of ourselves. By building minds the size of solar systems. And when we do, when that first Matryoshka brain comes online, it will be the culmination of 4 billion years of evolution. A single unbroken thread from the first replicating molecule to a god made of light and logic. Or maybe it will never happen. Maybe we will stay on Earth, living our small lives, looking up at the stars and wondering what could have been. Maybe the Matryoshka brain will remain forever in the realm of science fiction, a beautiful idea that never quite makes it to reality. I do not know which future we are headed toward. Nobody does. But I do know this. The fact that we can even conceive of something like a Matryoshka brain says something profound about us. It says we are a species that dreams big, that looks at a star, something ancient and powerful and almost incomprehensibly vast, and thinks, we could use that. We could make it part of us. It says we are not content with what we are. We want to grow, to expand, to become something more. And whether that ambition leads us to greatness or ruin, whether we build our Matryoshka brain or destroy ourselves trying, it is what makes us human. So here is my question for you. If we could build a Matryoshka brain, should we? If we had the technology, the resources, the ability to dismantle our solar system and turn it into the most powerful computer in the universe, would that be progress? Or would it be the ultimate act of hubris, destroying the very world that gave us life in pursuit of something we might not even understand? And if someone offered you the chance to upload your mind into that machine, to live forever in a simulated world, to think thoughts you cannot currently imagine, would you do it? Or would you choose to stay human, biological, mortal, limited, but real? Think about it, and let me know in the comments. Because this is not just a question about technology. It is a question about who we are and who we want to become. And I genuinely want to know what you think.